good?
Yeah.
All right, this is part 2, problems 6, 7, and 8. 6 is lengthy because it says to use logarithms. Well, when I write the original equation, I'm going to put them quantities to the powers. So when I take the natural log of both sides, I end up with the natural log of y equaling. Now I'm going to use the properties. If I have a product, I add, and if I have a quotient, I subtract. So this will be the natural log of x plus the natural log of this quantity, but the power becomes a coefficient, because that's one of our rules for logarithms. And then minus, again, the power becomes the coefficient. Oops, slight typo. So, you had to have it set up in this much before you can finish it. Now, the hard part will come in because when we take the derivative of this, we'll have 1 over y, d sub y, d sub x. So after we simplify this whole radical, we have to take it times this y when we get down to the end. All right, the derivative of natural log of x is?
What over x?
The derivative of this is 1 over x squared minus 1 times this derivative, which is 2x. And this is 1 over x plus 1, and the derivative of this is just 1. All right, are you good to here? Now, these 2's are going to drop out. So the next thing I want to do is get a common denominator, because it's going to be messy. Well, these have parentheses around them, okay? So in the denominator, I have a 3x in these two quantities, except this quantity is a factor of this one, because this is x minus 1, x plus 1. So basically, the common denominator will be 3x okay. So here, I need to take it times the 3, and then I'll have this quantity. And I'm just going to change it back to that. Here, I need a 3x, but I have an x here, so this one will be 3x squared. Again, I'm just looking at what's missing from this denominator, multiplying times the numerator. Here, I've got the 3, and I've got one quantity here, so I'm left with x minus 1, so I have 2 times x squared minus x.
Why wouldn't you just put minus 2x times x minus 1? Doesn't matter.
Because the next thing I'm going to do, see, I didn't do it here, so I was trying to be consistent. So now we have 3x squared minus 3 plus 3x squared minus 2x squared plus 2x. Okay, I'm going to multiply them back, because eventually I'm going to deal with this quantity up here. Okay? So, this is 6 minus 2, so that's 4x squared. Then I have a 2x and a minus 3. So, this is times 1 over y, d sub y, d sub x. And I need to deal with that 1 over y, which means I'm going to take this times that piece. Because this is just basically the y would be here. So we're going to have an x squared minus 1 to the 1/2. And here we'll have x plus 1 to the 2/3. So far, so good. Okay. This x and this x drop out. If I would move this one down here, because these two quantities are the same, this whole quantity will be gone, and I'll have a 1/2 down here. So, that's basically it. So we should end up in the numerator was 4x squared plus 2x minus 3. In the denominator, we still have the 3. We have an x squared minus 1 to the 1/2, and an x plus 1 to the 2/3.
Your answer's different.
My answer's different. I thought about that. I don't know how I got that cubic in there.
I agree with that one, no?
This one makes more sense. I don't know where I lost, where I gained an x.
And I would have gotten it probably, except for putting
Oh.
the exponents in front.
I know where I lost it. On this line here, oh, I multiplied the x
you
through.
you put the x in, because there's no more x's.
So that is the correct answer.
Yep.
So you can write the correct answer or not, whatever. All right, so this was number 6. Number 7 was supposed to be a light problem. It said you had to use the area formula for a circle. It says the radius of the circle is changing at a rate of a -2 pi meters per second. So they're telling us d sub r d sub t is equal to a -2 pi meters per second. What is the rate the circle's area is changing? So you're asked to find d sub a, d sub t, so that's what we're looking for, when r equals 10. So, back over here, you want to take the derivative of this in terms of time. So this is d sub a, d sub t. The derivative of this would be 2 pi r times d sub r, d sub t.
Okay.
Once you have this, you substitute your things in. So we're finding d sub a, d sub t is equal to 2 pi times 10 times a -2 pi. -40 pi squared. Now since this is area, this would be meters squared per second.
Okay.
But again, you need a formula that you can have, take the derivative in terms of a third variable.
Yeah, for some reason I was doing circumference and you wouldn't, and I couldn't use the r for anything, and it wasn't working.
And then the last problem was on the linearization. And the linearization is this guy. Is it plus or minus?
I just find the derivative and plug it in.
Because
You
I
wrote
think
plus on my sheet.
it's plus, yeah,
Yeah.
that's what I thought it was plus. So they gave you your f of x was 1 plus x to the 1/2 plus sine x minus 1/2. And then they told you that x was 0, so this is your a. So you need to find the derivative of this, and then evaluate at 0, and then evaluate this at 0, and then substitute.
Why can't you just do like a tangent line thing?
You can, but this is how they showed you how to do that.
Okay, because that's the way I did it in my paper and it worked, but,
Well, I don't know if they get messier.
yeah.
So if we take the derivative of this one, it's 1/2 the quantity to the 1 last power times the derivative of the inside, which is 1. The derivative of sine is cosine, and the derivative of that is gone. So when I want to do the derivative at 0, this becomes 1, so this is 1/2. The cosine at 0 is 1, right? So this is 3/2. So we'll put the 3/2 here times x minus 0. Then if I go back up to the original one and let x equal 0, here I'll have 1. The sine at 0 is 0 minus 1/2, so this is 1/2.
Oh,
So your linearization ends up to be 1/2 plus 3/2 x. Questions? Before we go on, though, I want to kind of give you a hint of what's on the test. Not yet. Not yet.
Screw you with your
Basically, I'm gonna give you the type of problems that you're gonna see on the test, if I can find the test. Unless I don't have it written on. Ah, here it is. So, the first couple of problems are asking you to find d sub y, d sub x. Then, they have one by logarithms. Then they have two where you have a to the x, so you need to go back and look at your rules for that. Yeah. All right, and then we have some inverse trig function ones, which you have powers, some with logarithms. Do you remember d sub y, what it's equal to? In that last section, remember we talked about it? It was equal to f prime of x times d sub x, or times delta x.
Oh, yeah,
That was
when
from-
you just add the d sub x to
Mhm.
the end of it.
Okay, you're gonna have a problem with that. You're also gonna have a linearization one, which is this, okay? Then you'll have a problem that talks like that area formula one. And they have some inverse ones you have to do, and they have a bonus one.
What is it?
There's 18 problems on this, and you have 2 days to work it out. Any questions you have for the test?